The ASA1 and ASA2 is booting up. So we connect. You can see the booting process. Okay. So here we are using which model? We are using 5.5. This is my personal lab. So here I don't have 5.5.1.6 as per Cisco lab. I have only 5.5.2.0. The only difference is instead of G1 by 1, we're gonna use
E0.
E0.
Yes.
E0. That's it. Okay. The booting is in progress. Okay, how do you confirm the which model it is? While booting, it will show you the model number, but in the CCIE app, you won't get this booting logs or anything. So you just get the console in the user mode.
Right.
You'll get like this. Okay.
Yeah.
So you get like this in the CCIE app. So you don't know which model it is. So what you do is you go here, Cisco. Now I'm gonna check the mode, show mode, single.
Yeah.
Right? This is how you see. So you want to break this firewall into two. So you have to change the default mode from single to multiple. I'll show you that what is the command you have to apply. But now I'm going to see which model number it is. Show version. You can see your 5.5.2. Can you see ASA 5.5.2.0?
Yes.
Okay. Same command you can apply on your CCIE lab to show you 5.5.1.6 or 5.5.1.2. If it is 5.5.1.6, the interface is gonna be M1 by M. I mean G1 by 1, G1 by 2, right? M1 by 1. Management is gonna be M1 by 1. If it is 5.5.1.1.2, it's gonna be G0 by 0, G0 by 1, G0 by 2. The management interface is gonna be M0 by 0.
Yeah.
But here I'm gonna use a 5.5.2.0 model. But here my interfaces are different. So you can, if you don't know this command, show version will give you which model. You can put like this: show version include 5.5.
Yeah.
I can see a 5.5.2.0. I'm including 5.5. This 5.5.
Yes.
So this shortcut will give you which model the firewall is. Okay.
Yeah.
99% is gonna be 5.5.1.6. Or if you don't know this command, what you can do is you can put a command show interface IP brief. From here it will show you. See, for me it's showing E0, E1, E2. So it means 5.5.2.0.
Yes.
But in your lab, in the CCIE lab, it will show you G1 by 1, G1 by 2, G1 by 3. Understand? M1 by 1. So in that case, it is 5.5.1.6. Okay, if it is showing G0 by 0, G0 by 1, M0 by 2, that's going to be 5.5.1.2.
Yes.
All right?
Yeah.
So ASA1 is ready. ASA2, again, I'm going to check the model number. Cisco, show version, include 5.5. It's also 5.5.2.0 model.
Yes.
Okay. Show mode. What mode it is operating? It's the single mode. Both are the single mode. In single mode, we cannot create context. We have to change the mode to multiple. So the moment you start your module 2 exam, you have to go to ASA1 immediately. First step, go to ASA1, configure terminal, show mode, check the mode. It's gonna show you single. You have to put a command, mode multiple. It will reboot. Okay, it will reboot. While rebooting, you will start configuring the first section. I mean, ASA1V you configure. Before you start configuring the ASA1V, 11V, or 2V or 22V for the active standby, you have to come to the physical firewall, ASA1 and ASA2, and apply the command mode multiple. Let it boot. right? You don't have to wait. You don't have time to look. I mean, look at the screen and watch the booting process,
Right.
right? So you come here again, configure terminal. Configure terminal, mode multiple, right? Let it boot. Right after it boots up, we will go and check the mode. It has to be in multiple mode. Both of them. Both
Right.
the firewall has to be in multiple mode. So I don't want to waste time. I'm going to bring the notepad and start configuring the commands.
Yes.
So let me take the design, right? So currently we are using 55
2 0.
5520. So instead of G1 by 1, I'm going to use E0.
Yes.
It's going to be E4. It's going to be E3. Got it? All right. Let me
Hold
bring
on.
the notepad.
E3 and E4. Yes.
Yes.
Okay. 0, 1, 2, 3, 4. Yeah. Okay.
So we are going to start task number 2.3, right? In the
Yes.
2.3 task, we have ASA1 and ASA2. 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 What is this task all about? This is contexting. Contexting. Okay. First step, failover. So ASA1, we're gonna configure failover. Which interface we're gonna use?
E3.
Interface E3, no shut, right? You can copy the same command. E4, no shut. Fine. Failover, LAN, unit, primary. Okay. Failover, LAN, interface is, what is the name written over here? It's LAN, right?
Okay.
We have to use the same name. Failover interface name, LAN, right?
Yes.
That is which interface? E3. Correct. E3 is the LAN interface. Fine. And we need to mention the link interface. Failover link is, the name gonna be state. That is E4. Any doubts on these two commands?
Okay. Hold on. The names for those are arbitrary, or does it have to be LAN and?
Yes, it has to be LAN and link. I mean state. It's not link. It has to be state. It is mentioned in the question. For
Okay.
example, let me show you the question. Okay, let me bring the question for you. So then you'll understand. Where is it? It's gonna be two. This is contexting. Okay. I'm gonna paste a question over here. This is a question. Okay, 2.3. You have been asked to deploy high availability on the ASAs in the core distribution layer of the network. Where is the core distribution layer? If you look at the design, can you see a core distribution?
Okay. Yes.
So that's what is mentioned. In the core distribution layer, we have to deploy high availability. Okay. ASA first, second, and third non-management interfaces must be inside. The name of the interface, DMZ. Name of the interface, outside source, respectively. Okay. We have to create two contacts, C1 and C2 must route traffic. So C1 will belong to sales, C2 represent finance organization respectively. Okay. The
Oh,
actual addresses of the sales and finance servers must be visible to the client. Who are the clients? The clients
that's
are these guys,
yeah.
the PCs. These are the clients. So the sales server and the finance server must be visible to these guys with IP address 1916.1.1, 1916.2.1.
Yeah.
What is the real IP address? The real IP address is
192.168.
192.168. Do a natting, and only
Yes.
we can achieve this. Okay.
Mm.
This IP address visible to the clients to access the sales and finance server. The last object of the management interface address must be 51 and 52. The
Mm.
management interface has to be .51 and 52. So what is the name you're gonna put? You're gonna put not NGMT. You're gonna put management as it is. You got it?
Yeah.
You got what I'm trying to say? Here, in the first line, it says the non-management interfaces must be inside the MZ, outside. We know what is the name we are supposed to use for the non-management interface. For the management interface, there is no name mentioned, which name has to be applied. So we have something called management over here. So that is the reason why we're gonna use this as the name for the management.
Okay. Hey Ram, can I
If you
get
look
can
at
I
the
have
previous,
Ram? Can I have 2 minutes?
yes,
Yeah, I'm gonna give a couple minutes. Run to the bathroom. I'll be right back.
no problem.
Okay. Okay. I'm sorry. I'm ready. So we have to call the management interface management.
All right.
Yes. I'm sorry.
Okay. So uh, let me ask you a question. You're able to understand my accent. I mean, I'm
Yes.
having an Indian accent. You're able to understand, right?
Yes.
Okay. If you have any issues, let me know. I don't
Oh,
have
okay.
your accent, but try to understand. Okay,
Okay.
but I can guarantee that you will get a good training from me.
Yes.
All right. So, um,
We're talking
so
about
that is the
management.
reason why we're gonna use the management name as management as it is, because it's nowhere mentioned MGMT,
Okay.
nowhere mentioned. Okay, but in the previous task, actually in the question paper, they have mentioned MGMT. That's why we
Okay.
use MGMT for them. Your question was why we were configuring like LAN and state, right? This
Yes.
LAN. Can you see here? It's LAN mentioned over here. State.
Okay.
Okay, that's the reason why I'm gonna use LAN. This LAN, this state. Got it?
Yes, sir.
All right. So these two commands are clear now.
Yes.
All right. Now I'm gonna configure the IP address. So failover interface IP for LAN is according to the design, it is 52201. Got one for this guy, dot two for this guy,
Mm-hmm.
right? So it is mentioned in the question paper here. Can you see?
Yeah.
The last octet of the active and standby LAN link in the phase addresses must be dot one and dot two, which means the active guy will always take dot one IP address. The standby will take dot two IP address.
Yes.
But the only exception is for the management interface. Management interface is 51 and 52.
Yeah.
Got it? So all the non-management interface doesn't matter. It is on ASA 11V, ASA 22V, ASA 1V, or ASA 2V, or even on the clustering. Dot one will be for the first firewall. Dot
Yeah.
two for the standby guy. Okay.
Mm-hmm.
Only difference is on the management interface. Management will have a separate IP address, not
Yes.
dot one or dot two. Fine.
Mm-hmm.
All right. So I'm gonna configure here 5.2.20.1. Okay. The standby IP and the mask is 24. Standby IP address is gonna be 5.2.201.2. Okay. This is the LAN interface. Now I'll copy this, duplicate it. I'll change the name LAN to state, and this is gonna be 202. 202. Okay.
Yes.
Why am I typing this? Because as per the design, it is 201 and 202. That is the reason why I'm going to use the same network.
Yeah.
Is that clear?
Yes, sir.
These 5 commands are clear. Any
Yeah.
doubts on these commands? All good, right? No.
Yes.
Now we have to create 2 groups. The group decides which contact is going to be the active and which one going to be the standby. So I'm going to create 2 groups. So failover group 1. Okay. The group 1 going to be the primary one. Primary, and you have to enable the preemption. You know the preemption, right? In the we have preemption on Palo Alto also, right?
Yes.
Palo Alto has got preemption on the active standby.
Mm-hmm.
So the preemption is enabled over here. Similarly, I'm going to create a group 2. Group 2, that is going to be the secondary. Again, preemption going to be enabled, and I will enable the failover. Okay, failover. This command I'm going to put it on ASA 1. Let me copy from here to here.
Okay.
Yeah, up until here, this much commands I have copied. So let me confirm line by line. E3 no shard, E4 no shard, primary LAN interface E3 state, E4 interface IP for LAN is fine. State is also fine. Failover group 1, primary, that's good. Looks good. Copy. I'll go to the server. This is how the Eve gonna looks like. Can you see the phase 1 and phase 2? Only the phase 1 devices are powered on, right?
Okay.
So you don't need to worry about this. You don't need to worry about this. This is how the lab is being designed.
Yeah.
But you need only this guy. Okay. ASA1. Enable Cisco configure terminal. I show mode. It's gonna be multiple now.
Yeah.
See? Multiple. ASA2 also I'm gonna check. Enable Cisco configure terminal show mode. Multiple, right?
Yes.
Good. So I have copied the configuration for ASA1. I'm gonna paste it here. Right? No errors. And what will I do? I'll go to the configuration. I'm just going to change this to secondary. I'm not going to type ASA2 configuration. Right? Copy. I'll go to ASA2. Right? I'm gonna paste it, and if my config is correct, I'll get a log here that detected an active meet. I'm waiting for the log to come. Yes.
Yep.
Okay. Detected an active meet. Now the replication of the config gonna happen. Because this is the context. I mean, this is the mode multiple. It takes some time to to synchronize each other and become the active and standby modes. So let me go and check. Show failover. Okay, it's in negotiation, right? And what you have to do is the CCIE lab, you have to get this one, 3 logs. This one, and group 2 pre-made. This 3 logs you are getting, your config is correct.
Okay.
So show failover. You can see the failover is on. It's a primary device. The LAN interface E3 is up, right?
Yes.
And this host is the primary one. The other host is secondary. The group number 1 is active, right?
Yes.
Group number 2 is standby on this firewall. But in the other host, group number 1 gonna be the standby. Group number 2 gonna be the active. So what we do is we will create 2 contacts, C1 and C2, because as per the question paper, it says we have to create 2 contacts here.
Yes.
You see the contacts C1 and C2, right? And the question says that the C1 has to be active on the ASA1 and C2 has to be active on ASA2. You can see here, the ASA1 C1 and ASA2 C2 must be active in pair for sales and finance traffic. Okay, this statement indicates that the C1 has to be active on ASA1 and C2 has to be active on ASA2.
Yes.
All right. So now, as you know, we have inside DMC and outside. We have 3 interfaces, right?
Yeah.
We have 3 interfaces. So we have to make those interfaces up now. So I'm going to make interface E0 up. No shut. This is gonna be this interface we're gonna use for the inside, right? Inside.
Yep.
Fine. So we have 2 contexts. So I have to break this interface E0.1, right? VLAN number 2, right?
Yes.
This will be for C1, context 1, and C2. This will be 2. This will be 3, right?
Yes.
Now, So this inside is over. Now I'm going to create DMZ. I'll simply copy this, duplicate it. I'll change this E0 to E1, E0 to E1, to E1, right? This will be 4, this will be 5. Now DMZ is over. Now I'm going to paste it again. If it's going to be E2, E2, and the VLAN number 6 and 7. 6 and 7. Any doubts on this? This is going to be the inside. This is going to be the DMZ. It's going to be the outside.
Okay.
Everywhere VLANs are different. So basically in the examination, all the candidates make mistakes here.
Right.
Most of all the candidates make mistakes here. Either they put a wrong interface ID or they will put the wrong VLAN number. Okay.
Yes.
So to avoid the mistakes, what you have to do is, let me show you how I do. Okay.
Okay.
Same. First, interface E0, not shut. This one, I know this is gonna be the inside interface, right? I know I need to create the sub interface. So again, interface E0 dot 1, VLAN number 2. Okay. I'll duplicate this. I'll change this to 2 and 3. Okay. First, I will create these 3 commands. Okay. Then I'll put an extra exclamation mark, right, to make sure that I have 3 such interfaces. I'll paste it again. I'll paste it. Okay. So 3 times. So this is the correct one, correct? And I pasted it 2 times. Fine. So E0, here E0 is there. I will change this E0 to E1. Here the E0 I'll change to E1. Here the E0 I'll change to E1. What is the next interface? E2. I'll change this to E2. This will be E2. This will be
E2.
Right? VLAN number 2, 3. I'll put this to 4. This to 5, 6, 7. No mistakes. No mistakes. Correct?
Right.
This is how you have to do in your lab. Okay?
Okay.
Fine. So 3 interfaces over. This is gonna be inside. This will take for the C1. This will go for the C2 inside. This will be E1. This is actually DMZ. This is DMZ for C1. This is DMZ for C2. Again, DMZ. I mean, this is outside for C1, outside for C2. Got it? And if you look at the design, we have a management interface, right? In the real lab, you will write here interface M1 by 1, no shut. Okay, but I'm using a 5520 model. I don't have M1 by 1. I don't have a management interface. For example, let me go to the firewall. I'll show you the show interface IP bridge command. Show interface IP bridge. Do I have a management interface? Show IP interface bridge. Show IP interface brief.
Oh, show interface IP brief on the ASA?
Yes. Show interface IP brief. Okay, see here. Do I have a management interface?
No.
I don't have, right? But I'm gonna use E5 as a management. Okay.
Okay.
Just for our practice purpose. This 5520 doesn't have a management interface, so I have an E5 interface. I'm gonna use that as the management. So that is why I'm gonna change this to E5. No shut. That's it. Okay. Now we have enabled all the interfaces, right? Next step is we have to create the context. So I'm going to create the first context C1, okay, context C1, and this will join the group number one, join one. That's the
Okay.
shortcut, join one. So which means I'm going to execute this command on ASA1. ASA1, you know, in that we have created two groups and said group number one is
Primary.
active. Yeah, the primary one.
Yeah.
And the group two is going to be the secondary one. So I'm going to tell that a context C1, you join group number one. So which means ASA1, it will be active. Right? Now I have to allocate the resources. Resources means the interfaces. So allocate interface. Which interface I have to allocate? E1 by 1,
Yeah.
E0 by 1. This interface I have to allocate. E0 by 1. Okay. We can put a name. As per the question paper, it says that we have to use a name for this interface as inside C1. Can you see here inside C1? The context C1 interface must be named as inside C1, outside C1, here is the C1. So that is why I'm going to put the name here, inside C1. Okay. Now we need DMZ and outside. So you copy this, paste it 2 times, change this to E1, and just to E2. This will be DMZ, will be outside. Okay. Any doubts on this config?
No.
Okay. We are putting these names because the question paper says us to do this.
Yes.
As we have shown. Now, whatever configurations we are going to make on context C1, we need to create a CFG file, a configuration file. Okay. So CFG file is mandatory. Whenever you create a context, you need to create the CFG file, the configuration file on the flash or disk 0. So what is the command for doing that? Config URL disk 0 C1 dot CFG config file. So these are the 5 commands to create a context. So what are the steps? The steps are create the context, tell the context which group the context has to be the member, and the third step is allocate the interfaces and assign the name. Even if you're not putting a name, it will work. But as per the question paper, it says we have to put these names.
Okay.
So we created the context. We told the context to join a particular group. We have allocated the resources, and we're gonna create the config file. These are the steps. Don't miss any of this. 1,
Okay.
2, and 3. Similarly, I'm gonna create context number 2. So you don't have to type anything. Just simply copy this, duplicate it. Okay. Wherever you have 1, change to 2. 2, 2, 2, 2, 2. E1 will change to 2, and this E1 will change to 2, dot 2, dot. That's it. Easy, right?
Yes.
Second context created. Now you have to create an admin context. Admin context is already there. For example, if you go to the firewall, show context. Can you see there's an admin context?
Yes.
Who created this? It's by default.
By default. Yes.
By default. What is the name of the config file? Admin.cfg, right? admin.cfg. So this admin context we are basically using for management purpose. Okay, just for management purpose, we use the admin context.
Okay.
So I'm gonna duplicate this configuration. This one I have copied. Paste it. Okay, I'm gonna change this C1 to admin context. Okay, admin context will join group number 1, which means the admin context and the C1 context will be active on ASA1.
1.
Is that clear? The
Yes.
admin context and the C1 will be active on ASA1. If you want the admin context to be active on ASA2, what you do is
Join 2.
you just change to 2.
Yeah.
But as we need to create like this,
Okay.
mandatory. Okay, we have to keep it like that. Now allocate interface. Which interface we are using? E5, right? E5.
Okay.
E5 is one of the management interface. So in the real lab, you will type here M1 by 1.
Okay.
M1 by 1. Here we are going to use E5. No name. If you want a name, you can put management. That's up to you. But normally, when I did the lab, I never put a name right here.
Okay.
Here I'll put it as admin. Got it?
Yes.
So I'm going to copy this command and paste and ensure that my VLANs are created and the contexts are working. So let me copy this. Copy. So you see how much from where to where I copy. I copy up to here. I already pasted. Right. The failover is active now. Now I'm going to copy the interfaces and I'm going to copy the context. Copy. If my commands are, I'm not sure my commands are correct. I believe these are correct commands.
Okay.
Okay. I'm going to the design, the console of ASA1. Right. Currently we have only one context. I'm going to paste it. Okay. No issues here. No issues. I know there are no issues.
Okay.
Okay. Now show context. How many contexts has to be there?
3.
Here. Admin context is here. Which interface? E5. Correct, right?
Yes.
C1 context is there. There are 3 interfaces. The name is C1, right? C2 is there and 3 interfaces. This is the verification command you have to use in the real lab. Exam also you have to confirm this. Then only you should go forward. You should see there are 3 contexts active. Okay?
Yes.
So here you have to confirm these are 1, 1, 1. Here it's 2, 2, 2.
Yes.
Okay? Now that part is done. Now we have to configure the individual context. So the contexts are created now. Now we are going to jump to context C1. So change to context command, change CHAN, change to context C1. Okay. If I put this command, let's see what is the change going to happen on the mode. Is it okay? This is a config mode, right?
Yes.
I'm going to paste the command. Can you see the mode has changed? Say 1/C1. Now we are inside the context. Now we are inside the virtual file.
Right.
Right? Now, what we're gonna do? We're gonna start configuring this file. We're gonna configure the interface first. Interface, we have to copy this name now. You must copy this name. You cannot copy this interface ID now. It doesn't work. This doesn't work from now onwards. Okay. You have to copy the respective name. Copy from here, paste. Okay, name if inside. Okay, name if inside. Security level 100. IP address. What is the VLAN number we have used for this interface? E0.1. We used VLAN number 2. See, VLAN number 2. So that is why this interface IP address is going to be 5.2.2.1, 255.255.255.0, standby 5.2.2.2. Notion. Any doubts on this config? You there?
I'm sorry, I was muted. No, no questions.
Okay, this is clear, right?
Yes,
I've jumped to the context. I've created the inside C1 interface because I've told that E0 by 1, I'm going to call this interface as inside C1 from now on.
Yes.
So I just went to the inside C1. I put the name, security level 100. Why did I put inside? Because the question paper says that I have to use inside.
Okay.
Right? Where is it mentioned here? Can you see here inside? DMZ is capital DMZ. Outside.
Yes.
So inside is down. Now I'll duplicate this, copy, paste. I'll paste one more because I need DMZ and outside. So I duplicated this 2 times. Now this will be outside C1. Sorry, DMZ C1. Right? I've copied. I'll copy this. I'm gonna make it as DMZ C1. This has to be capital DMZ.
Mm-hmm.
Okay. In the examination, many candidates will make mistake. They will type DMZ. It's wrong. It's wrong.
Okay.
It has to be capital DMZ because in the question paper, it says that we have to use DMZ. Can you see here?
Capital. Yes.
These are capitals. All right. So DMZ, the security level is not mentioned anywhere, so we can put anywhere value other than 100 or 0. So I'm gonna put it as 50.
Okay.
Okay. Here 52522. So it's gonna be 5224. 5224. The VLAN number 5. VLAN number 4. Again, this is gonna be outside. Out. This is outside. Security level gonna be 0. So 2, 4, 6 gonna come. 6 and 6. The interfaces are being configured.
Yep.
Okay. Now we have to put a command whenever you do contexting. Right after you configure your interfaces, you have to start monitoring the interface. So monitor interface inside. Copy paste. It's gonna be out. This is DMZ, and last interface is gonna be outside. Okay.
Yes.
Outside. But when you do the normal active standby, you don't have to put this command because it's already there. These commands are already there in normal active standby config. For example, if I go here, this is a virtual firewall. Here we have implemented the active standby.
Yes.
So here, if I'm putting show failover, it shows it's being monitored. Can you see it's being monitored? But when it comes to the contexting, it won't show you as monitored. It is show as unmonitored.
Okay.
Okay, or not monitored. So if it is non-monitored, it is our responsibility to make it monitored. What
Okay.
is the command for enabling that?
Monitor interface.
Monitor. Yeah.
Okay.
So in the lab, you don't have to type monitor hyphen, just type mon. That's enough.
Okay.
MON. Okay, now the monitoring is done. Okay. Now, as per the design, the context C1 is using EIGRP, right? AJRP1, right? So which means when I configure AJRP, I have to get 3 neighbors. One is this guy R6,
Yeah.
one is R7, one is R9. 3
Right.
neighbors I have to get for context E1.
Yes.
Similarly, I have to get 3 neighbors for
Context.
RS2 as well. But the only difference is R8 gonna come as one of the neighbor.
Yes.
Right? So let me start configuring the AHRP. So what I will do is router AHRP1 network. What you do is simply copy this 5221.0 like this. Okay, paste, copy, paste 3 times. So 2, 4, and 6. All right.
Yes.
AHRP is done. Now here it is saying, the question says that we have to create NATing. Can you see here? The actual addresses of the sales and finance server must be visible to the clients with this IP address. 9060.101.2.1, right?
Yes.
So which means we have to perform NATing on this context. So I'm going to create an object network. Okay, for sales. Okay, what is the transferred IP address? As per the question, we have 1916.101, right?
Yes.
And again, object network, the real IP address, network sales, it's not transferred IP address. The real network is host 192.168.1.1.
Okay.
NAT. When the NATing has to happen, whenever traffic goes from DMZ to outside or outside to DMZ, anything. So DMZ to outside, statically convert, right? This IP to this IP. So just simply copy this name and paste.
Okay.
That's it. End of story. Got it? This is the NATing. 5 lines only. Okay. You're gonna define the IP which is gonna used by the clients to access the sales server, right? So definitely you have to mention the real sales server private IP address, and you're gonna NAT it. Whenever traffic goes from DMZ to outside or outside to DMZ, statically convert this IP address to this IP. Yeah.
Yes.
Any doubts?
No.
No. So one more point you have to understand is when we deploy the AnyConnect VPN. Okay, consider that we have deployed the AnyConnect VPN. Okay, and this guy has authenticated with this firewall, AnyConnect VPN. So whenever he uses AnyConnect VPN, we will configure this guy that you allocate an IP address from this range 172.16, 1.12, 172.16, 1.10. From this range, you allocate one IP to the AnyConnect adapter. Got it?
Okay.
So if you're aware of this of AnyConnect VPN, you understand what I'm trying to say.
Yeah.
For example, this guy is a remote user, right?
Yes.
This guy has to access a particular server in your data center. So basically, he has to use AnyConnect VPN or any kind of VPN,
Yes.
which gives a private connectivity to your network.
Yes.
So when this guy authenticates with this firewall, this firewall will assign an IP address to this guy.
Yes. So
AnyConnect
private IP. Okay. Yeah.
Yes. That IP address for the sales is in a range of 172.16,
Oh, 1 through 10.
1.1 to
Yeah.
172.16, 1.10.
Yes.
Similarly, when the finance PC connect, this guy will allocate an IP address pool from ranging from 172.16, 1.11 to 172.16, 1.20.
Yes.
This is for sales.
So,
This is for finance.
oh, yes.
Is that clear?
Yes.
So whenever whenever the sales PC wants to access this guy, right?
Yep.
It'll come like this, right? And it goes like this, goes here, goes here, goes here, goes here, goes here. What is the source IP? When suppose this guy he has successfully connected AnyConnect,
Yeah.
right? He is trying to ping 19.16.1.1. Okay,
He's gonna have
116.1.1.
172.16 press.
1.1. So the source IP gonna be 172.16.1.x, any IP from that particular range, this guy is
Yes.
allocated, right?
Yes.
So the traffic which gonna hit here, the source IP is 172.16.1. Let's say 1.2, right? Correct. Similarly, here also, whenever this guy connect, he will also get the same network, right? 172.16 range will be different, but the
Yes.
network address is gonna be same, correct?
Yes.
So suppose this guy is sending traffic, it goes like this, comes here, go to the firewall, this guy will divert the traffic to this guy, right? And goes here. Here also again, 172.16, 1 dot, maybe it is 12,
Yes.
correct? So the security level here is 0, this is 50, this is 100. By default, ASA firewall won't allow any traffic from low security to high security.
Right.
But from high security to low security, it is permitted. It is inspected and sending the traffic out.
Yes.
Fine. But now, when this guy tries to access this guy, the traffic is going from 0 to 50, right?
Yes.
Which is not allowed. It is not permitted. To permit it, what we have to do?
Access list.
We have access list. So this guy operates as a HTTP server. This guy is also HTTP server. What is the port number of HTTP? 80.
80. Yes.
80. But here we have statically configured that it's not 80, it is 8080.
Yes. High level port. Yes.
Okay, 8080. So whenever this guy wants to access the web page of this guy, he will go like this: HTTP colon 19.16.1.1
Forward.
colon 8080.
Yes.
This is TCP, right?
Yes.
TCP. Port number 8080. This is what we have to allow on this guy, right? ACL.
Yes.
So I'm going to type the ACL now.
Permit.
Access list. Okay. It's a sales department, right? So we can put a name sales ACL or sales. It's up to you. Let's say sales.
Yes.
Sales ACL. Permit. Who? Permit what? Permit TCP, right?
Yes.
TCP from where? 172.16 1.0. 255.255.255.0. Right? To where? To host this guy. Right? To host this IP address. Which port number?
88.
Right? Similarly, we have to permit ICMP as well. ICMP. So permit
ICMP.
ICMP. That's it. Okay. Now I'm gonna bind it on the interface. Access group. Access group. What is the name of the access list? Sales ACL,
Yeah.
right?
Yes.
In interface outside. This is the command. Okay. This is the command. Any doubts on this ACL?
No.
Okay. Good. Why did I use ICMP?
For validation that you can
Question.
reach the server.
No, the question paper says to permit ICMP. Let's read the question.
Oh, okay. I didn't see it. I'm sorry. Yeah.
Okay. The question paper somewhere says that we have to permit ICMP as well as 172. So one more thing you have to understand is you will not get all the parameters, all the things to be configured on 2.3 from this task. You won't get. Cisco has mixed up. For example, you know 2.1 is active standby failover. Simple
Yeah.
active standby failover on ASA 1V and ASA
11.
11V,
Yeah.
right? 2.2 is also same active standby, but the
Yes.
only difference is this one 2V and 22V.
Yes.
Then you have 2.3. This is what we are discussing now. This is active
Context.
on ASA 1 and ASA 2,
Yes.
and 2.4 is your clustering.
Okay.
That is on ASA 3 and ASA 4, right? But I said oh, it's some important point out. Okay, I said yes. One more point is the 172 subnet I was talking about, right? 172.16.1.0/24, right? For the sales, I said we have to use a range 172.16.1.1 to 172.16.1.10. Where is it mentioned? It is not mentioned in this particular task, to this task. But we are permitting here. How do we know this is a network? So we have two more tasks in ASA firewall. That is 1.2. That is any connect VPN. And we have 1.3. That is SSL VPN.
Yeah.
Believe me, if you want to configure anything on ASA 1V, ASA 11V, ASA 1, ASA 2, these firewalls, you have to read 1, 2, and 3. 3 tasks you have to read. Then only you'll get the entire information. You got it?
Yes.
So 172.16 is nowhere mentioned. So here it is not there because we never seen in 2.1 172 subnet. It's not mentioned anywhere. 2.3 we are doing now, but in the question paper it's not mentioned anywhere. It's 172.16, right?
Okay.
Now only choice is 1.2. So let me bring the 1.2 question over here.
Okay.
I'm going to paste the 1.2 away. This is a 1.2. Can you see this 172.16?
Yes.
Right? The sales organization must be from 172.16. That is the reason why I'm going to use it. The sales. And for the finance, it has to be from 11 to 20. Right?
Mm.
See the port number 8080. It's mentioned as a separate question. Correct? So if he doesn't understand how Cisco has formulated the question, he won't be able to get the information, right?
Okay.
He won't be able to. So all the questions are connected back to back. Some information will be, this is 1.2. When you read this question, some information won't be available, but the information which is not available is available on the other questions.
Yes.
Okay. So that's the point. I'm using this network. Which task I'm doing? I'm doing task number 2.3.
Yes.
But this information is available in 1.2.
Yes.
In 1.2. Okay.
Okay.
Can you see the names inside, outside, management? These are which firewall? These are
The V firewalls.
V firewalls.
Yes.
These are the V firewalls. Okay. But if you read the 2.1 question, the names are not mentioned. Let me bring the 2.1 question. When we type the command, we have used inside, outside, MGMT, right?
Yes.
Those names are from here, from task 1.2. When we configure task number 2.1,
Yeah.
you didn't ask this question. How did you get this outside, inside, MGMT?
Right.
But I know it is there in 1.2.
Okay.
Okay. So whenever you configure something and you are missing some information, right? Don't panic. You just have to go to the other task related with ASF hour. It will be mentioned.
Okay.
It will be mentioned. Right. Let's start configuring. So that's it. That's the end of story up to here. So 8080 is mentioned in the question paper, right? 8080.
Yes.
And why am I opening ICMP? It says that I have to
Allow
ICMP.
Yes.
Allow ICMP, right? ICMP destined to 172.16 1.0 subnet. Okay. Now, remove this.
Hold
So
on.
this is a command we have to.
Can you go back to the ICMP question? I'm sorry. So ICMP destined to 172.16.1 network. Our rule looks like it's destined to
1916.101 or 192, right?
yeah.
But this question 1.2 is talking about a virtual firewall.
Okay.
So what does this question say? This question is telling you when you connect any connect, right?
Yes.
When you successfully establish the any connect VPN, is my pen. A very, very good question you ask. What is the IP address you're gonna get here? Let's say 172, 61.2. This guy will get 172, 61. Let's say 12.
Yeah.
Right? Cisco is telling you you should be able to ping from this IP to this IP. So you have to have a access list over here, right?
Yes.
That has to permit 172 subnet. That's what the question paper is saying. 172.16.0
Okay.
ICMP has to be coupled. So when you try to ping from year to year, even though they are in the internet, the traffic will go something like this. Comes here, comes here, comes like this, and goes. Okay, it's not talking about the ACL on the virtual. I mean the context. It's not there.
Right. Okay.
It's not
Okay.
talking about that.
All
Okay,
right.
fine. Now, so that's a configuration. So let's start pasting it. Up to here, we pasted and we verified the contexts are available. These interfaces are available, right? We have already verified all those things
Yes.
that you can see over here, right?
Mm-hmm.
We have verified all this up to here. Fine. Now
Yes.
I'm going to start configuring the context C1.
Yes.
C1. So change to C1. Let me paste the interface commands up to here. Copy, paste. Okay. Show failover, not monitor,
Right.
not monitor. So what is the command to monitor? Monitor
Monitor.
inside, monitor outside, monitor.
Yes.
Copy, paste, enter. Now again, I'm going to put the same command, show failover. Waiting, it's waiting. It takes some time. It takes 10 to 15 seconds to become monitored.
Okay.
Okay. Waiting again. Waiting again. So let it wait. Not a problem. We don't have time to waste. We'll come back and check later. Okay. Next is EIGRP. Copy this. In the examination, you have to do exactly what I'm doing here. One
Yes.
by one, you have to paste. Don't paste the entire commands all together. This piece by piece, we have to paste and verify. Now I'm gonna put the EIGRP configuration. I have to get 3 EIGRP neighbors. If I'm not getting EIGRP neighbors, something went wrong.
Yes.
Something has gone wrong. Okay. So again, I'm going to the server. I mean the firewall. I'm gonna check what is the status of the monitoring. Okay, failover. It's monitored now. Okay.
Okay. Yes.
Good. EIGRP configuration I'm pasting. Right. This is a very critical command, and this verification will show you that whatever configuration you have already done is correct or not. If you're not getting neighborship, then there is something wrong. Show EIGRP neighbors.
Yeah.
EIGRP neighbors. I have to get 3 neighbors. Good.
Yes.
Right? I
Yeah.
have formed the neighborship with R9, which is the outside router.
Mm-hmm.
R7, this is my DMZ. R6 is inside. Good to go.
Yes.
No queue count, right?
Right.
Maybe you will get 1 queue count or 2 queue count. Don't worry, even if you're getting queue count, just check EIGRP neighbors again. As long as you're getting 3 neighbors, your configuration is perfect.
Right.
All right. Now I'm going to create the natting. Copy. Paste. Good. And I'm going to create the paste. Copy. Paste. Something wrong. There's no space.
Right.
ICMP space. Right. I hope these are the only commands. I can copy it again.
No, I don't think it likes ICMP there.
Can you see here? There's no space here.
Okay.
It gave
Okay.
me an error.
Yep.
It gave me an error. So I
Yeah.
understand that there's no space over here.
Right.
Now I put a space here.
Yes. Okay.
Okay. Now you tell me, looking at this design, when this guy authenticates himself using the indicated VPN, he will get an IP address on 172 subnet, right? You know
Yes.
about it.
Yes.
And to reach this guy, he has to come with which IP address? He has to send traffic to which IP address? He has to
19
send to
1.1.
19.16.101,
Yeah.
right? So this is 172.16.101. You want to go here, you have to go with 19.16.1.1,
Yeah.
right? The traffic comes here, right? We'll check the destination, he'll check the routing table for this network, right?
Mm-hmm.
Does he has 19.16.101? Have we configured this route on the firewall?
Not there, I don't think.
No. We have not configured. We have configured only these two subnets on
Right.
this guy. He doesn't know about 19.16.101, right? Similarly,
Right.
when this guy reaches 19.16.1.2, again, he doesn't know about this route, right?
Right.
So we have to make him aware of these two routes. We have to configure here two more static routes. One is for 19.16.1.1
Yes.
and 19.16.1.2, right? So not 1.2, 2.1. And this is 1.1 and 2.1. We have to configure this. What is the next stop? Next stop has to be router 9,
Right.
correct?
Yes.
So what we do is, so whenever you type these two static routes on your firewall, ASA1B, you know you have two routes, right?
Yes.
Now you should have two more routes: 19.16.101, 255, 255, 255, 255,
Mm-hmm.
right? 5.2.8.9. You're gonna send to R9. Now, similarly, if any traffic comes to 2.1, send to same guy, correct?
Yes.
I'm gonna paste this command on ASA
1B.
1V. So now if I put a command show route, it will not have any routes for 906101 show routes. Do we have route 906101? We don't have, right?
No.
So I'm gonna create route. I didn't mention the interface. Route inside,
Right.
right? This is correct. This is connected to which broadcast domain? Inside, right? If
Yes.
we didn't write inside. So this is the command. Copy and paste. Fine. Now, again, look at the design.
Yes.
From here, 9016.101 will come here. You will send to R9.
Right.
Correct? Similarly, 9062.1 comes from here like this. You will send to R9.
Yes.
Now, what R9 will do? Does R9 has a route to 9016.101 and 2.1? Let's go and check.
Yeah, let's check.
R9. R9, R9. R9 is over here. Okay. Enable, configure terminal, do show IP route. No routes. No 906101. So we have to configure those routes on R9 as well. Right?
Yes. Yes.
So let's go to the notepad. So here we need R9 as well. R9. What we gonna tell? IP route. Sorry, IP route 1961.1 to 552.552.552.555. Sent to whom?
ASA.
Context ASA1 context C1
Okay.
outside interface, that is 5.2.6.1. Correct or not? Five
Yeah.
two six one, right?
Yeah. Okay.
Right.
Yes.
And what about
2.1.
2.1? What is the next shop?
Whatever VLAN 7 is. Is it 7.1? 5.2.7.1? 3.5.7.
Yes,
5.2.7.
7.1. It's 7.1. 7.1, right?
Yes.
We'll send to ASA2 now.
Yes.
5271. 527. So R9. Copy. Go to R9. Good to go, right?
Yes.
So now look at the design once again. How
Mhm.
far the traffic is going.
So it's getting inside to the firewalls
Now
and then natting in context 1.
from here, the traffic gonna come here. It goes here. We have already created a static route. Next stop is over here. From here, it goes here, right?
Yes.
Until here is fine. Similarly, from here, the traffic will come, goes here. It will send the traffic to this guy. Correct?
Yes.
Now we have a natting, right? We have a natting. Now with the destination IP on this blue traffic is 19.16.1.1.
Yes.
This is 19.16.2.1.
2.1. Yes.
Right? We have already configured a natting. Says that when 19.16 comes from outside,
Go DMZ.
convert to to DMZ.
Yeah.
From outside to DMZ, converted to 192, 168, 101. We have configured already, right?
Yes.
So we need to ensure the natting is actually working, right?
Yes.
So how do we ensure that? We have configured an ACL here. First, the first ACL saying that permit TCP from 170 to 16, right?
Yes.
But we haven't configured any connect VPN here, so we cannot test it. We cannot test that natting is working, correct?
Okay.
You understand? Because we haven't configured any connect VPN. This guy doesn't have an 172 subnet IP address,
Oh, right. Yeah. We haven't put it on his machine.
right?
Okay. Yeah.
So if we would have we would have this, then we can test the natting is working or not. Correct.
Right.
And we have permitted ICMP for 172 subnet. Oh man, we can't test it now.
Mm.
But what we can do is I'm going to permit ICMP any for both the context. Okay. Then I will go to R9 and I'll ping 19.16.1.1.
Mm-hmm.
The traffic goes here. Here I am gonna put an additional command permit ICMP any,
Mm-hmm.
right? So it doesn't check the source
Then,
IP address. Anything
right.
is allowed. Nothing gonna work. If I'm getting a reply back, then the NAT thing I have configured is correct. Correct.
Yes.
So for testing purpose, only for testing purpose in the CCA lab, we will do this command. Only for testing. So what we're gonna do with the ACL, we have typed over here these two lines, right? We copy this statement,
Yes.
permit ICMP,
Annie.
any. Okay. Any. I'm going to paste this command on context C1. ASA 1. You go to ASA 1, paste. Okay. Now I'll go to R9. Do ping 1916.101. If I'm getting a reply, my natting is working perfectly.
Yeah.
Working.
That's good. Yeah.
Okay. I'm going to remove the statement. No. Oops. No. Will I be able to ping? No.
Nope.
Right? So which means my natting is perfectly working. This is how we test in the lab.
Okay.
Okay. So now we are ensuring end-to-end. Correct?
Yes.
So once you are getting the reply, immediately come here, put a no on the statement because this statement is not permitted in the lab.
Right.
The Cisco has not asked to configure this. They have asked to configure only two commands. One is to permit the TCP traffic to port number 8080 and ICMP traffic from 172.16.1.0 subnet.
Mm-hmm.
Got it?
Yes.
Now we have so that's the end of the context C1 configuration.
Right.
Okay. Now what about C2? So you have to copy from here, right?
Yes.
Up until here, including the ICMP and any command, right?
Yeah.
Paste it. So wherever you have C1, can change to C2. C2.
Yeah.
C2. 2 will change to villa number 3.
3. Yes.
3. DMC C2. 4 will change to 5.
5. Mm-hmm.
Whatever number you have, plus 1. And this here is going to be, oh, I forgot changes. C2. Okay.
7.
7 and 7. Everything same. EHRP2. Look at the design.
Mm-hmm.
EHRP2 over here, right?
Yep. 3, 5, 7. Yeah.
So, yes. So that's why I put 2. Now this is 3, 5, and 7. Okay, I haven't typed these commands. I simply copy from here,
Yes.
from here, and paste it. I don't care because I'm gonna check only these 3 options.
Right.
So I don't want to put here 0. It doesn't. So even if you put like this, then if you check the HRP configuration again, it's gonna be like 5250.
Yeah.
So don't type and waste your time in the CCA lab. So you just copy from here and paste it and change the respective numbers.
Yeah.
So 357, that's fine. Now this will be finance, right? Finance. It's going to be 2.1. It's going to be again finance, right?
Yes.
This will be 2.1.
2.1.
And this will be finance again. Dash T. And the name, it will be finance. Finance ACL, finance ACL, finance ACL. Okay. This is going to be 2.1. Going to be 2.1. This will be finance. That's it. So
Yes.
here you don't have to worry because you know you got the output for context C1, so you can completely copy this command.
Okay.
One time paste. Okay.
Yes.
One time paste. You can go to ASA 2. You must go to ASA 2 because here the context C2 is active.
Right.
Okay. Don't paste it here. If you paste it here, then it gives you tons of errors.
Okay.
Okay. Then you'll end up in rebooting both the firewalls.
Got it.
So make sure context C2 command, you'll come to ASA2 and paste it. The monitor 3, 5, 7, right?
Yes.
AGRP DMZ is 357 again. Yes, sir. Right?
Yes.
I'm gonna check the EHRP neighbors now. Show EHRP. I must get 3 neighbors. Good. Can you see the queue count is 2 here?
Yes.
So again, I'm checking 0. Good.
Yeah.
I'm going to online and test. Online and test 2.1 now. Good.
Yes.
1.1.
No good.
Good.
Okay.
Right? So these guys has got a domain name. So 1916 1.1, the domain name is dupin sales.cisco.com. See, I got the same IP address, right?
Right.
So just note it down. Sales.cisco.com is nothing but 1916 101.
Right.
Okay. And what about 1916 2.1? That is finance.
Finance.
So dupin finance.cisco.com. Cool, right? So now, right after you confirm the reachability, this reachability indicates you that your NATing is perfect.
Right.
Your context configuration is perfect. Everything you did on context C1 and C2 are perfect. If you are getting this output, if you're getting this reachability. All right. Right after you get, what you do is you come to the context one, show run access list, because we have to remove that ICMP yes. Show run access list. Okay. Now remove this. Copy. Nope. Fine. Similarly, go to ASA2. Right. Show run access list. Access list. And remove the statement. And now if you go to R9, you won't get the reply. So hello.
Yes, I'm here.
Okay, I lost connectivity to internet, so I
Oh,
connected to a different Wi-Fi network. Let me see. I'm getting reachability. No packet loss. Oh God, I'm getting. You can hear me, right?
yes.
I'm getting packet loss in Google.com. Okay. See, I'm not getting the reachability. Okay, because I removed the
The AC.
ACL.
Right. Yeah.
Similarly, so my two contexts are configured well, and I'm getting the proper output. Fine.
Yeah.
Now we have little more commands to complete here. As you know, we have got a context called admin context, right, for the management purpose.
Yes.
Fine. So we have to configure very few commands on those on admin context. So what we do is change to context admin, right?
Okay.
And which interface we are going to use for admin context interface? E5.
E5, yeah.
But in the real lab, we're going to use M1
MGM1.
by 1.
Yes, M11.
No,
Okay.
M1 by 1, because this is a 5516 model.
Yes.
If it is a 5512 model, you're going to use M0 by 0.
Yes.
Okay. So here I'm using E5. Okay. Name if it is management, MANAGEM. So the question paper says that we have to use MANAGEM management. Okay.
Yes.
Security level 100. So you don't have to type all these actually. You don't have to type all this because you have already typed these set of commands through your previous task. For example, ASA1V, ASA11V, you have already typed this command. So just go
Okay.
there and pick those configurations. For example, yes, these commands. Yes, from here to here. Up to here you can go.
Okay.
Okay. This configuration, you can paste it over here. Only few changes. This is gonna be MANAGEM management. Then copy this same name, change the management to management. This inside also you'll change to management when it comes to the context part. IP address is gonna be 51 and 52. Everything else same. Cool, right?
Yes.
One more command, monitor interface management. That's it, man. You're done with the contexting task.
Okay.
So admin context is active on which firewall? ASA1 or ASA2?
Yes.
ASA1.
Yeah.
Okay. So paste. I got some error. I use M0 by 0. So that's why it gave me error. So I have to use E5. B.
Yes.
Paste.
E5.
Now it's fine. All right.
Yes.
Show failover. It's showing waiting. After some time, maybe 15 to 20 seconds, it's gonna be monitor. That's it. End of story. So 3 tasks over.
Right.
In the ASA firewall. Okay.
Yes.
Now we're gonna do one more task. That is task number 2.4.
Oh, okay.
That is your clustering.
Oh, yes.
Clustering. And you're gonna work with ASA3 and ASA4. ASA4. Okay. Let's begin. Can you hear me?
Yes.
Okay. Now let's look at the design. Yeah. Now we are here.
Yep.
ASA3 and ASA4. Okay.
Okay.
And we have a cluster configuration link, right? This is not going to show you in the CCA lab, or we have highlighted in the gray color.
Yes.
It's not visible in the real topology, right? So basically what we are trying to do here, we're going to club these 2 firewall into a single firewall, right? So that both of them will carry the traffic at the same time.
Right.
Right? So as per the question paper, it says that ASA3 has to be the master and ASA4 has to be the slave.
Yes.
Okay. And also you can see here the OSPF neighborship, OSPF area 1 between the router 13 and the cluster.
Okay.
and OSPF area 2 between the cluster and the marketing server, R14. So basically, here also you have inside, outside, and DMZ.
DMZ. Yeah.
Okay. Then you can see here outside. Outside interface gonna connect to R15. DMZ interface gonna connect to your R14. Forget about these switches, okay? These switches we don't have access in the real lab.
Okay.
Switch 2P and switch 1P, we don't have access. So don't worry about it. You just assume that this firewall is directly connected to the router port.
Right.
Fine.
Yes.
So here we are using OSPF under area 0, 1, and 2. Outside is under area 0, inside is under area 1, and DMZ is under area 2.
Yep.
Fine.
Yes.
And you can see here R14 is having a loopback interface that is having the marketing server, which is a HTTPS server.
Okay.
4340 server. Okay. Similarly, R13 that is connected to the inside interface, right? And it's having an engineering server. The IP address is 192.168.4.1.443.
Right.
All right. So goal is to configure clustering, right? The
Yes.
question paper says that the first 2 interfaces have to be used for either channel, right?
Yes.
Either channel, and the third interface has to be used for the cluster configuration, CCIE link. Fine.
Okay. Yes.
So let's begin the configuration. I need the design. Okay. Interface. Okay. In the CCIE lab, this firewall is also 5516. So
Okay.
you will have G1 by 1, G1 by 2, G1 by 3 interfaces.
Okay.
But in my lab, I'm using
Again.
5520.
Okay.
So I'm going to use E0, E1, E2.
Yes.
So E2, now shut. So this interface I'm going to use as a CCIE link, cluster configuration. Okay. I'm going to input this command on ASA3. ASA3. Okay. Interface E2. Cluster interface mode. Span. First command. Enable clustering. Okay. Plus
Yes.
this command will enable clustering on the firewall. Cluster interface mode. Span. Now I'm going to create a group, cluster group. I'm going to put a name, cluster group CCIE. Okay. And in this group, I have a local unit, ASA3. Okay. And I'm going to set the priority. This guy is going to be the master, so I'm going to set the priority number 1. And which interface I'm going to use as a cluster interface? So cluster interface. Cluster interface is E2, and its IP is 52203.1. Mask is 255.255.255.0. Right?
Yes.
In the examination, you have to put one command called MTU cluster. This command won't take work in my lab. Okay, that's why I'm putting an exclamation mark in the very beginning.
Okay.
MTU cluster 9000. Then you have to reload the device to activate this MTU to 9000. In the real lab, you have to do this command, but in my practical lab, you don't have to. But you have to make a habit of typing these commands.
Right.
Okay, because these commands must be executed in the real lab.
Okay.
If you don't put a reload, this will not have an impact. That is why we are putting a reload.
Okay.
So this command will go to ASA 3. Let me see my configs are correct. I'm not sure it's correct or not. I mean, any typo there, I don't know. I'm going to the firewalls, ASA3 and ASA4. 3 over here. Enable Cisco, configure terminal, and paste it. Good. No errors. Fine.
Yes.
Now, the same configuration I'm going to duplicate for ASA4. This is going to be ASA4. The name going to be ASA4. The priority going to be higher than ASA3. So I'm going to put 2 or 100. It's up to you. But anyway, it is not 1. IP address is going to be .2. That's it. So this config will go to ASA2.
Okay.
So not ASA2, ASA4.
All right.
ASA2 is for context. Config terminal. Good. Okay.
Okay.
Let me try to ping the neighbor. That is, I'm in ASA4 ping .1. Reachable. Right?
Yes.
From ASA4, ASA3 is reachable. But I haven't activated. I have not made any election. Election I will do later, not now. Okay. There is a reason for not executing that enable no confirm command. I mean, I don't want the election now.
Okay.
I want the election later. Otherwise, what is going to happen is if you enable election here and when you execute some certain commands, the master will leave the election. I mean, the master will leave the cluster, right? And
Okay.
he goes to a disable state. I don't want that. If it goes to disable, it's hectic, man. We have to again activate the failover. Sometimes it may not work. Maybe the port channel will go down. So we don't want any headaches in the CCIE lab. So you have to follow the steps I'm following now. So
Okay.
I have enabled the clustering configuration, right? But the election is
Yes.
not conducted. The election is still pending. I have not told the firewalls, okay, start the election. I didn't do that. There's a reason why, because if I do that, executing few other commands going forward may lead the master firewall to leave the cluster.
Right.
It takes a lot of time to recover or troubleshoot the issue.
Right.
Got it? Yeah.
Yes.
Now, before I move forward, let me show you how the physical connectivity is. Here you have ASA 3, ASA 4, 2 firewalls, right? You have a switch here, switch 2. Okay, physical switch. This is the physical switch. I think it's a 3560 model, 3500 series model. Here one interface is connected, here one interface is connected. Fine?
Yes.
And these one interface connected like this. This is actually your CCL link. This interface is E2. This is also E2. The network address is 52.0.3.0/24. That's why I used this IP for this .2. Okay. And here you have E1. Here also E1. Then one more link is connected here. This is E2. One more link is connected here. This is E2. Okay. You got it?
Well,
From here,
slow down. The drawing was slow. 1 second. E1, E. Hmm. So there's
all
two
right.
there's two E2 interfaces on the ASA.
Oh, sorry. This is E0. This is E0. E0.
Okay.
E0. Okay.
Okay.
Good. Good.
E0, E0,
E0.
E1. Okay. Okay.
E0, E1, and E2. The question paper says that use the last interface. Use the first two interface for 4-channel, and
Yeah.
the next interface for the CCL link.
Okay. I got it. Yes, sir.
All right. So now S2 is again connected to R13, right? This is
Yeah.
connected to R14. Here we have got the engineering server. We're having an IP address 192.168.1. R14 we have a server that is the marketing server, right? This is working on HTTPS 443 port. Here we have 192.168 3.1 again on 443 port.
Mm-hmm.
And we have one more router connected over here. This is R15, right?
Yes.
This is the inside. This will be inside. This is DMZ outside. Correct? And
Yeah.
what are we going to do? What are we going to do is here in my lab, I'm going to use this interface as G0 by 0. This is G0 by 1. This is G0 by 2. G0 by 3. You got it?
1 second. The drawing is slow. Okay, on the switch. G0, 01, 02, 03. Yes.
In my lab. In the real lab, the G0 by 0 is G1 by 0 by 1. The real lab. Because here I'm using a virtual switch.
Yes.
But here in the CCI lab, it's a physical switch.
Okay.
The 35 series switch. That's why we have slots like this. And G0 by 1, the lab, the CCI lab is G1 by 0 by 2. Got it? And again,
Yeah.
G0 by 2 of the switch in the CCI lab is G1 by 0 by 4. And here it is G0 by 3 is G1 by 0 by 5. Okay? Is that clear?
1, 2, 4, 5, not 1, 2, 3, 4.
No, not 1, 2, 3, 4.
Okay.
So if you look at the design, let me
Yeah.
show you that connectivity in the design. Okay? In the corner, can you see here? In the corner. We come here. Here. 1, 2, 4, 5.
Oh, okay.
Okay?
Yes.
So what about 3? 3 is going to the management interface.
Yes.
This is going to the management interface. Okay, is that clear?
Yes.
1, 2, 4, 5.
Okay.
So right after I execute these commands, what I'll do is I'll come to the switch. Which switch? switch to P. Okay, switch to P. The real app you will type like this: interface range 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 G1 by 0 by 1 to 2, comma G1 by 0 by
4 to 5.
4 to 5. Okay, but I'm not going to use this on my lab. I'm
Right.
gonna put an exclamation mark here. I'm gonna do interface range G0 by 0 to 3
Yeah.
for interfaces. Okay.
Yes.
Switchport trunk encapsulation dot one q. Switchport mode trunk, right?
Yes.
Switchport trunk allowed VLANs are 13, 14, and 15. 13 to 15. No shut. Okay. But I have to bundle these, right?
Yes.
So what will I do is I will put a command channel group 1 mode active. So this is the command I'm going to use.
Yeah.
Okay.
Yep.
So again, when you execute this command, you'll get a port channel 1, right? So interface PO1.
Mm.
You can again copy this command and paste. It's not required, but you do like this, it's well good. Okay.
Okay.
Intentionally, I'm gonna make it shut down. Okay. I'll
Okay.
shut down this interface. Why? Because when the cluster becomes active, right?
Yes.
That time I will make it up. Fine, this is a switch 2 configuration. So let me copy this configuration and put it on the switch 2.
Okay.
B. The switch to P is over here. Can you see here? Switch to switches. Okay. Enable Cisco. Configure terminal. I'm gonna paste. Good, right?
Yes.
So to make it clean like this, because we need to get the log. Once I put a no shut command here, I need to get the log that the PO1 is up. Fine.
Okay.
The
Yes.
next, what will I do is copy this configuration because we need this for ASA3. Okay. Interface E0 shut down. Okay. No shut. And copy. Next is interface E1. Two interfaces. I'm gonna bundle. Right? Any doubts
No.
on the SFR? Now interface PO1 port channel span cluster command here. Okay.
Mm-hmm.
Port channel span cluster, and you shut down the interface. We will later we make this interface up.
Okay.
All right. Now we have got a port channel, right? We have got a single interface, right?
Right.
And what we're gonna do is we're gonna break this interface with PO1.13, VLAN 13. If you look at the design, you'll be able to understand the VLAN numbers. So this is PO13, right?
Right.
Why it is 13? Because it is going to connect to R13. That is why
Yeah.
it's called P113. But here it is P of 14. Why it is
Yes.
connecting to
VLAN 14,
14 and
14.
P of
Yeah.
15.
Wow.
15. So which means we have to use whenever there's a sub interface, we have to use the respective VLAN, right?
Yes.
So P13, VLAN number 13 is gonna be name is inside,
Yes.
right? Security level 100. IP address 5.2.13.1. Okay. Okay. So one interface over, second interface, third interface. So 3 times I'm gonna paste. Keep it like this. So this is gonna be 14, 14. This is also 14, and this is gonna be DMZ. Here it's small DMZ. Okay, not capital. 15. That's it. Now 15, 15 is gonna be outside. It's gonna be 0. It's gonna be okay. This is clear.
Yes.
Now next is we can enable OSPF. So router OSPF 1 network. Just copy this command as it is. Area 0. Copy and paste 2 times. This is gonna be 30. You will change this to 1 area 1. Gonna be 14. Gonna be area 2. Confirm this before you go forward. So 15 is area 0. That is fine. You can see right here. Then 13 is area 1. Area 1, that's fine. And 14 is area 2. Any doubts?
Nope.
Okay. Now in the CCIE lab, you won't paste this in this order. You paste the router OSPF command only at the end. But you have to type like this. Now you put a space and you're gonna configure here something else. Okay. You're gonna create the natting object network marketing translator here. Yes. Host is 1916 3.1. Again, you copy this, duplicate it. So real IP address that is 192.168. 3.1. NAT from DMZ to outside. It's not capital DMZ, small DMZ. Outside, statically convert with this IP. Any doubts on this statement? Here, what we're gonna do is, if anybody comes from here and hit the firewall with 1916 3.1, convert that IP to this. This is what we do. Anybody comes to 1916 3.1, convert that to 192.168.3.1. The traffic has to be from DMZ to outside. Then only you have to convert. Similarly, we have to do the static NATing for engineering server.
Yes.
So this will be engineering. Engineering translated, network address is 1916.4.1. Right?
Yes.
And this has to be engineering. translated. This has to be, or make sure you change this to inside. Otherwise, you won't get output. So now this traffic is coming from inside to outside, right? This is inside.
Right.
If you don't do this, you won't get the output. Most of all my students make this mistake.
Right.
Almost everyone, they forgot to change this to inside. They come to me and say, I'm not getting reachability to engineering server. The only thing, the problem is this is they used it as DMZ because they copied from it.
Right.
Now, ACL, access list, right?
Mm-hmm.
And put a name servers, permit TCP. From whom? Here it was 172.16, right?
Yes.
In the lab, actually, they were asking to configure a SSL VPN. SSL VPN, what's going to happen is this guy will send the traffic to this guy, right? Here we will configure SSL VPN, right?
Yes.
So what is going to happen is this guy will act as a proxy. He won't use this IP address. He will use the outside interface IP address and send the traffic to the servers, either to the engineering server or marketing server.
Right.
Okay. He will use its inside IP address, not outside. Inside IP address he'll be using to generate the traffic. So when the traffic hits the firewall, what is the source IP address? This will come over the firewall.
Yeah.
The firewall will act as a proxy. He will use his inside IP address as source IP address and the traffic on behalf of the engineering PC or marketing PC. So what is the source IP address hitting the firewall?
52.16.
Yes, 5.2.16. That so we have to use that IP as a IP inside the ACL.
Right.
It is 5.2.16.1. Okay, so we have to use something called host. The traffic coming from only this guy to host this guy 3.1
Mm-hmm.
equals 443. Similarly, when traffic comes from this guy to 4.1 also permits, right?
Yep.
That's it. No ICMP is permitted here. But for testing purpose, to ensure the NATing is working, we permit ICMP any and access group servers in interface outside. All right.
Yep.
So that's the configuration. Now again, we have to configure the management interface. So management interface is common. Every firewall, any ASI firewall take the management setup, management command sets are common. You can simply copy from any firewall and put it over here, do some minor adjustments. So what I'm going to do is I'm going to copy the management config. Here I have configured some management config, right? I want to copy this. And here I'm going to paste it. Okay. So before that, in clustering, we have to create a local pool. Local pool. Why we need to create a local pool? Try to understand. How many firewalls we have here? 2 firewalls.
2. Yeah.
Right? The cluster will have, the cluster means a big firewall.
Yes.
Right? Basically, we can see 2 firewalls. When we do the clustering, it's a single logical firewall, a powerful firewall.
Yeah.
So that will have a management IP address 55. It is a CCL management interface 55.
Okay.
But these are individual management IP addresses. So to configure this IP addresses in the way we have seen, we can see on the topology, we have to create a local. So I want to create it, IP local pool. Let's say management pool, MG pool. Right? What is the network? Network is 151.7.56 and 57. 57. And the mask is 255, 255, 255. Okay. Now when you come to manage E5, management interface configuration, right? So because we are using a E5 interface, we have to make it non-management. Command is management only. Management only statement we have to use. But in the real lab, you don't have to use this. In the real lab, instead of E5, you're gonna use M1 by 1. In that case, management only is not required.
Okay.
But here, to accept this command, we have to use management only. Everything is fine. Maybe if you can use MGMT because it's not mentioned to use management. Here we use 150 to 53. So what is the IP address here? For the management, this is 55, right? Yeah, 55.
Yes.
So where is it? This is 55. Okay. And here cluster pool.
Right. It's 55 through 57. Yeah.
Yes.
Okay.
Management. Okay. One more thing. When we configure the OSPF interfaces, right? Here. We have to configure one more command, that is OSPF priority 0, because we want this guy to be the master.
Okay.
You know the GR on BDR, right? We want this guy to be the GR. So we configure this command. OSPF priority 0.
Yeah.
Everything looks good. Copy, paste, management, monitor management is not required. I think that's it.
Okay.
So afterwards, you have to paste this down. Then we start configuring. So this is already pasted, right?
Yes.
Now let's copy the commands of port channel. Let's see this command is working. So ASA read. That's good. Okay, these commands are working fine. Next is I'm going to create the interfaces, 3 interfaces. Inside 100, DMC 50, 14, here 15, 15, all good. Right, where is 15.1? Right, now I'm going to create the static netting. You confirm it again, object network marketing 90%, marketing 10.1, DMC outside. fine. Okay. Engineering is the 964 This is good. In inside to outside. It is also good. So copy. Paste. All good. Right?
Yes.
Now we have got the ACLs. I'm putting the ICMP in any. Why? To test the NATing.
Testing. Yeah.
Later I'll come and delete it. Okay. And I'm going to put this over here. That's good. I'm going to create the management pool. Start is also good. Now I'm going to create the management IP. Okay.
Okay. I also have a question. Why is the
Yep.
the local management pool 56 and 57 and not 55 through 57?
If you look at the topology, the cluster pool cluster is 55 and this is 51. Individual is 56 and 57.
Okay. So if there were three, I think I understand. Never mind. Yes. So the main cluster is 55. The cluster pool has 56 and 57 inside of it. Okay.
Exactly. Exactly. Yes.
I
You're
understand.
right.
Sorry. Yeah.
That's
Go
why
ahead.
I use a big stick over here.
Right.
Bigger one.
Yeah.
Okay.
Okay.
But you won't find this in the lab. Okay. You won't find this in the lab. Just for your understanding.
Okay.
That's what I'm saying. Going forward, you don't need this topology. You don't have to look at this topology. You know the cluster pool IP is 55. And
Right. Okay.
all right. Now up until here, I think we have pasted this command. Let's see. Good.
Yep.
Fine. Now we have to make the channel up. The channel up. So, before I make the either channel up, I have to activate the clustering. Show run cluster. Show run cluster. Okay. Just simply copy this, paste it, and enable no conform command on the master. Enter. And we go to the ASA4, enable as slave. So you have to wait for nearly 30 to 40 seconds to begin the election process, right? In between, we confirm that the peer is reachable 52203.2. It's good.
Mm-hmm.
So let's wait. But in the CCIE lab, you don't wait. You go and do some other task.
Okay.
That's fine. We will wait for 30 to 40 seconds. If our config is correct, we will see the logs saying that this guy is master, the other guy is slave.
Right.
And the config is replicating, synchronization in progress. Those things we will see. Let's wait. Okay, begin.
Okay.
right?
Yes.
So if you have noticed, it is exactly 40 seconds, I believe. You
Yes.
can, when you start practicing, you can open a timer and see that 40 seconds takes. Because if somebody doesn't know, it takes some time for the selection process. You know, they think that the configuration is wrong. They may reboot the firewall. They change some. They do some modifications. You know, they mess up everything. They
Right.
doesn't know there's a waiting period of 40 seconds.
Okay.
You understand what I mean?
Yes.
Okay. I'm gonna check the cluster information. Show cluster info. I wanna see this guy is a master and the other guy is a slave.
Right.
Yes, this guy is a master and the guy is a slave. Fine. Now
Yes.
I'm gonna enable the port channel. So interface, if you look the interface port channel, it's down. In the show interface IP brief, the port channel is administratively down, right?
Okay.
And same in the switch, it's down. Port
Yeah.
channel. Yeah. So enable Cisco configure terminal. Right, interface range G0 by 0 to 3. No shut. Enter. Your interface PO1. Interface PO1. No shut. Now, if everything goes well, we'll see a log here that the port channel there's a log here. So which means the port channel came up.
Okay.
Confirm that. Do show the channel summary. Right. Begin with dash dash. You can see the port channel is up, but we have G0 by 2 in waiting state. That is not good for us. Confirm it again. It's waiting. It should not be waiting. Okay, let me shut down it again. Shut down. We'll go to the firewall. Shut down. Show interface. IP brief. Interface tier 1. No shut. I'm not going to execute it at the moment. I'm going to put no shut here. Enter. And yeah, enter. Let's see. Yes. Do show the channel summary. Do show the channel summary. Now it's good. Okay.
There we go. Yes.
So once the port channel is up, what you do is you have to load balance with the source IP and destination IP. The command is port channel load balance source destination IP. This command is valid. Okay.
Okay. Hold on.
Good. Now we're gonna do what? OSPF.
Okay.
P. Okay, we need to get 3 neighbors. If you are not getting neighbors, something wrong. Show OSPF neighbor. 2 neighbors only. 3 neighbors. Good. Good. Okay,
All right.
this is what we have to get. But see, 13, 14, 15, they are DR,
Yeah.
right? They are the DR. We don't
Yeah.
want those guys to be the DR. We want the ASA cluster has to be the DR.
Okay.
So what we have to do is we have to go to R14, R13, and R15. Okay. We have to input a command to clear the OSP process. So it's a command do clear IP OSPF process. Enter. Yes. Copy this command. Enter. Similarly, go to R40.
14.
Enable Cisco configure terminal. Paste. Yes. Clear the OSPF process. Enable Cisco configure terminal. Paste. Okay, now let's go and check who is the master now. I mean, who is the DR? They are the still the DR, right?
Yeah.
It is wrong. They cannot be the DR. They cannot be the DR. So let's do one more time. Do clear IP OSPF process. Yes. Never is down. Do clear IP OSPF process. Yes. Do clear IP OSPF process. Yes. Oh, you know what? I made a mistake. The mistake is I think I have configured priority 0. This cannot be a DR ever. It has to be 255.
Okay.
Highest priority will become the DR, right? Not the lowest one. 255. That's why right after I clear the OSPF process on the router 13, 14, 15, the ASA firewall still stays as DRO.
Right. DR right there. Okay.
It's gonna be DRO.
Yeah.
That is 0. For example, do show IP OSPF neighbor. It's gonna be DRO because the priority is 0. See DRO.
Right. The higher priority, right?
0 will be DRO always. So you have to make sure you put 255. Okay.
Okay.
Because everybody makes this mistake because when you do the cluster configuration, the lowest priority will become the master.
Okay.
You're gonna do the same approach for the OSPF as well. So you put the lowest value to make the DR, but actually for OSPF it is
The highest. Okay.
the highest has to be the DR. So now I'm gonna copy this and paste copy S3, right? Now if I clear, then should be good. Yes. Yes. And off it. Yes. Okay, now we can test. Show SPF neighbor. It's BDR,
Right.
which means I'm the DR. All good. Right?
There we go.
Now we can test. Now let's look at the design now.
Okay.
Similar approach we have to do what we did on R9 and ASA firewall, right?
Yes.
Consider that the SSL VPN, this guy gonna initiate the connection to 1916 3.1. So this is engineering PC, right? So engineering PC will connect the engineering server. Comes here. Let me show you the R13 as well. That's fine. So let's consider marketing PC. Marketing PC has to access the marketing server, right?
Yes.
This guy has to access this server. Let's see. You will send the traffic to the firewall. Firewall will act as a proxy. It's going to take the G0 by 0 IP address and send the traffic. This is how the traffic has to flow, right?
Yes.
But what was the destination IP address for this guy, for this traffic? 19, 16, 3.1, right?
Yes.
Correct. Does this guy aware of this route?
Probably not.
He is not. But he is aware of this route and this route. Statically, we have configured. He is unaware of 1916 3.1. So we have to configure static route, right?
Yes.
Similarly, when the traffic comes from this guy, the destination IP is going to be 192.168, sorry, 119.16 4.1.
Mm-hmm.
This guy is unaware, right?
Yes.
So let's configure that. So whenever you configure section 2.2, you have to input these commands. So section 2.2. Yeah. Routes inside 1916 3.1 sent to R15, right? 5.2.16.15. Correct. That's correct. Let's put it on where? On R15.
Yes.
So no, it's not R15, it's on ASA 2V, right?
Yes.
Right? So ASA is aware of the route. Now the traffic, any traffic comes to 9063.1 or 4.1, it will send to R15. Let's see from R15 perspective.
We have a route.
What R15 gonna do?
Be
So
sending
now the traffic will go from here. Let's say the green traffic coming from the marketing PC.
Mm-hmm.
It goes to this guy.
R15.
R15. Does R15 is aware of this route?
I don't think so. No.
No, he is not. Similarly, your engineering traffic again goes here. He is not aware of this route. So we have to make him aware against static route. So here R15 IP routes 1916 3.1 255.255.255.255. You will send to the cluster 5 to 15.1, right?
Mm.
Again 4.1 is sent to 15.1. Is that correct?
Yes.
15.1 is the IP address of the outside interface.
Yes.
Right? Copy. Let's confirm 15.1.
Oh, yeah, the port
15.1 outside. Now we go to R15. That's good. Now we have to test it, right? We have to test netting is working. We have already permitted any ICMP any,
Yes.
right? So you will test it from not R50.
From the
Okay?
firewall. ASAV.
From the firewall. ASA2V.
2V. Yeah.
Right?
Yes.
Ping 1916 3.1. Good.
Yep.
4.1. You can also try using the domain name that is marketing server
Yep.
Cisco.com. Mm-hmm.
Isn't it called marketing?
Marketing server Cisco.com is not reachable. Ping engineering server.cisco.com. There is some error. Show run DNS. Show run DNS. That's good. Marketing. Oh, it's being marketing.cisco.com.
Yeah. No server. Yeah.
Marketing.cisco.com. Show out. Yes, I understand. The reason is it doesn't have route to DNS. Okay. So, but we have reachability ping 1916 3.1.
Yes, but
And
that
4.1. As
200
long
is
as we are
not
getting the reachability is fine. But the only thing is the domain name resolution is not happening.
right. No,
Okay.
nothing to that
Ping
200.
151.7.200. We have the reachability, but this reachability is happening to the management interface.
Right.
Right? But we have configured that the DNS domain lookup should be via inside. Show run DNS. You see here?
Yes.
So that's why the domain name resolution is not happening. But the domain name resolution will happen when we configure the SSL VPN. When we start configuring the SSL VPN, we will have additional commands.
Okay.
We will have additional commands. Okay.
All right.
So I think this ends the configuration of ASA1, ASA2, ASA3, ASA4. Now
Okay.
we are left with what? We are left with SSL VPN
Yes.
and AnyConnect VPN. These two VPNs. So in these two VPNs, we configure these two tabs not using commands. We use ASD.
Okay. Yes. Yeah. Okay.
This takes, we use commands. Suppose you are using the command set. It takes at least 10 to 15 minutes or 20 minutes with error, without output. You will end up. So ASDM configuration, I'll show you how to configure it, and it takes hardly, let's say, less than 10 minutes.
Okay.
Okay, SSL VPN is very simple. It takes 5 minutes to get the output.
Okay.
But apart from this ASDM configuration, we have to add a couple of other commands. For example, we have to define the split tunnel traffic,
Right.
right? And
Yes.
we have to permit what all traffic has to be permitted through the tunnel.
Right.
So that is actually mentioned in the question. It says that the traffic from 170 to subnet has to be permitted. The DNS traffic has to be permitted. The NTP traffic has to be permitted. Let me show you that. There in this. No, I'll get that question. This is okay. Anyconnect VPN question looks like this. You see the translated address to the sales server for port number 88. Okay.
Yes.
DNS server, NTP server, ICMP traffic. Okay, let me finish all the command sets. Okay. And
Okay.
tomorrow I'll show you only the ASDM.
Okay.
Let me do this as well. Okay. 1.2. Now, after completing this, we will jump to AnyConnect. Okay. In AnyConnect VPN, what you have to do is, it says the DNS traffic and NTP server also has to be permitted, right?
Yes.
Fine. So, which means when you configure the static routing on task 2.1, together with this, you will add two more statements. One is to the NTP server.
Right.
Okay, let's put DNS server first. 200, right?
Yes.
And NTP server.
NTP.
231. These two commands are manual. Okay. And also, when it goes to SSL VPN, when it comes to the SSL VPN, you will take this command and put it on. Yep. See, now the DNS has come. Right?
Okay.
So let me paste this command and see. The domain resolution is happening. Right?
Yes.
Now, being marketing server.cisco.com working, right? Just because this root is missing.
Right.
Engineering server.cisco.com. Cool.
Yes.
Right?
Yes.
So we come back here. So these are the roots we added. Now, let me tell you, these are actually related with the VPN configuration, SSL VPN.
Okay.
From here, your SSL VPN gonna be SSL VPN commands. SSL VPN, this is the ASA1B, right? So AnyConnect VPN.
Okay.
These commands are related with AnyConnect. If you look at the question, it says that we have to permit the traffic to DNS server, NTP server, and ICMP traffic to 170 to 16. Those things are mentioned over here. Okay. So AnyConnect VPN is done. So this is done. Now we have to define the split tunnel, which all traffic has to go through the tunnel. So for that we define a standard ACL. So access list, right? Permits host 1916.1.1. This traffic has to go through the access list. We have to define a name, right? Let's say sales split tunnel, right? Permit this IP address. Then the DNS traffic has to go, NTP traffic has to go, and the 170 to subnet. So this has to be this IP address. This has to be the NTP traffic, and this has to be the 172.16.1.0, 255.255.255. These are the split tunnel traffic. Okay. Only whenever any traffic comes from the sales PC, this traffic will be encrypted using IPsec IP2. Okay. Now,
Yeah.
now all the traffic will go, right? Whenever
Right.
the destination IP address belongs to this, any traffic, doesn't matter if it's TCP, UDP, or ICMP, but it is mentioned in the question paper that only certain traffic has to go. What are those certain traffic? Let's
80.
Let me bring it for you. Yeah, I'm gonna put it over here. Now those traffic, these are the traffics. Okay, so we have to mention a standard ACL. So using standard ACL, we can define the port number and protocol. All those stuff we can mention, right? So now I'm gonna mention access list, sales extended. Okay, permit TCP from any. Okay, so it's, the question paper says that Cisco anytime session must be assigned dynamic ACL to permit traffic from any. Okay, that's why I'm using any. Okay, let me. This is a question. Okay, Cisco any session must be assigned dynamic ACL that permit traffic from source to this network, and this network. So permit TCP any to host 1916.1.1 equal 88. Correct?
Yes.
Now permit UDP any to this guy, right? 53.
Yep.
And also you have to mention TCP. In case the DNS server is working on a TCP protocol, then this has to be there. Okay.
Yeah.
And next NTP traffic. So UDP is gonna be NTP traffic to 31. The port number gonna be 1. And you have to permit the ICMP for for uh, for this guy. So put it here, permit ICMP from any to this guy. Also, one more ICMP from any to 172.16.1.0. 255.255.255. Okay, this is the traffic we have to permit. Okay, let me tell you. When this traffic comes, right, we will permit TCP traffic on port number 8080. Correct?
Yes.
Next is ICMP also we are gonna permit. That's right, ICMP.
Right.
Okay. Then it is mentioned in the question paper that ICMP destined to 172.16 also should be permitted. That's why I'm going to use this. Then only the sales PC and finance PC can ping each other. Remember, I told you when they connect using the AnyConnect, they will get IP address from 172 to subnet. So when this guy wanna ping this guy using the VPN, the traffic will go to the firewall, comes back, and here. For this to come back like this, we have to use a command permit intra communication.
Right.
Now the security level is 0 here, right? So
Yes.
0 to 0 it's going. The same security level communication, right?
Yes.
So we have to permit we have to put a command same security traffic permit intra interface command has to be executed. Otherwise you won't get the output. that command will input at the last. Apart from that, we have to permit the TCP UDP for the DNS and the
Yeah.
NTP traffic, right? And from which pool they have to obtain the IP address. So IP local pool for sales, let's say pool that is from 172.16.101 to 172.16.110, right? And the mask is 255.255.255. So this is all about the sales. Now for the finance, you copy this, paste. This is gonna be finance. Finance. Copy, paste, paste, paste. Again, all sales will change to finance. 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 Copy, paste, 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 paste. This is finance pool. Okay, let's edit one by one. The finance is gonna be 2.1, correct?
Yes.
And this is fine. This up to here is fine. And here this is again gonna be 2.1. This is 2.1. All these are fine, right? The pool has to be 11 to 20. Okay. Why? Because in the question paper,
Yes.
it says like this. Let me copy and paste it for you.
Yes. Sales is 1 to 10. Finance is 11 through 20.
Right?
Yes.
Then to activate this statement, right? This statement and this statement, you have to put a command. Same security traffic permit intra interface.
Yeah.
Okay. So any kind of VPN configuration start from here. So let me copy these. This is already pasted, I guess. These configs are already there. This direct route configuration. This is not ASA2V. ASA paste. Okay, these roots are fine. I think already we have executed those commands. As you can see over here, it's already there. But these two commands were not there.
Right.
Next, ACL, internal ACL and external ACL, along with the sales pool. Right? Let's go here and paste it. Good. And again, copy and paste it. All right, that's it.
Right.
That's it. So that's the end of all the command sets related with phase one. So phase one command sets. Okay, phase one command set is not completed because stealth watch is still pending. Stealth watch, we have got a couple of commands to be executed on R9. But when we look from the ASA perspective, all the command sets are completed successfully.
Okay.
Right? So what is pending now? So let's see what are completed. Task number 2.1 is about active standby failover on ASA 1V and ASA 11V is done. Right?
Yes.
2.2, active standby on ASA 2V and 22V is done. 2.3, active on ASA 1 and 2 is done. 2.4 cluster on ASA 3 and 4 is done.
Yes.
Now 1.2 CLI part is done, and 1.3 there's no CLI. Yeah, CLI part is also done. We have a static route command, right, for the DNS.
Right.
CLI part is done. So up to here is done. Today we have completed all this. Tomorrow we're gonna do the ASDM part of this, right?
Okay.
We're gonna do the ASDM part of this as well, and we'll configure ICE.
Okay.
Fine.
Yep. Sounds good.
All right. So one more thing I want to tell you is, even though we configure this, right? These are the external ACL, right? These external ACLs, you can configure locally on the firewall, or you can configure these ACLs on ICE.
Okay.
So I suggest in the CCIE lab exam, don't do this. You don't have to do this. You have to put these statements on ICE. When you authenticate from your sales PC or finance PC, the authentication will go to the ICE. ICE will push the DACL, the downloadable ACL,
Yeah.
this guy, to the firewall. Okay.
Got it.
Two ways it will work. So I don't recommend this method. We have to use ICE.
Okay.
So what actually we need? We need only, we don't need this, right? We don't need this. Got it?
Okay.
But those statements we're gonna put it on ICE tomorrow.
Okay.
Any questions you have? We are gonna wind up the class.
Not really. I guess you're gonna share that file with me, and what should I be doing tonight?
Yes. So how are we gonna practice all this?
Yeah, that because they said I have lab access after class or something. Yes, I'm trying to figure out how do you want me to practice?
So after class you have yes, you have the lab access. I'll give you access to the same lab, right?
Okay.
You can practice. But what I'm planning tomorrow is I don't want you to sit for a long period, okay? Because you will get frustrated and so many things, man. We are discussing so many things. Right?
Yeah.
So
Right.
what I'm planning is we don't need actually 5 days of CCIE lab completers. Today we have completed 1.2. I mean, we have completed 2.1, 2.2, 2.3, 2.4, right?
Okay.
And 1.2 part half, not even half, and 1.3. So 4 tasks we finished. We finished completely, right?
Okay. Yeah.
These are CLI. That's why we are taking so much of time. If it is a GUI part, it takes very less time.
Okay.
So today itself, the first day itself, we have finished nearly 4 tasks.
Okay.
Main task. So tomorrow we'll finish another 4 tasks, 4 or 5 tasks, depends on. I don't think tomorrow it's gonna take this much time, because tomorrow we're gonna do with ASDM, doesn't take much time.
Okay.
So my point is tomorrow we will do for 4 hours.
Okay.
Okay, we'll discuss 4 hours of lab. I mean, the task by task we discuss 4 hours. Then I'll give you access to the rack, to this rack,
Yes.
and you can practice.
Okay.
I will monitor it.
Okay.
Got it.
And then you told me I need to
Tomorrow,
draw out the lab.
yeah, Yeah, tomorrow, yes. Tomorrow, what I will do is tomorrow from 7:30. I mean, it's my Indian time. Your time is different.
Okay.
My time for your training session is 7:30 to 3:30.
Okay.
This is AM. So this is PM to AM. This is my time. Yours is different. Okay.
Okay.
So this is actually 8 hours.
Right.
So tomorrow from 7:30 to 8:30, 9:30, 10:30, 11:30, I'll train you on 1.2, 1.3, right?
Okay.
That I think 4 point, which one? What is
Stealth Watch 4.6.
Stealth Watch 4.6? 4.6 I'll discuss. Then from here we discuss .1x 3.1. Session 3 also we discuss tomorrow.
Okay.
Section 3. Section 3 we have 3.1, 3.2, 3.3 and 4.1. Apart from that, we have to, there are some dependent tasks, that is RPCL, that is 3.4. Then we need to have Flex VPN, that is 1.5. So tomorrow in the first 4 hours, I'll discuss this.
Okay.
And right after the 4 hours, I'll give you access to the rack.
Okay.
You can practice as today's session. So we have discussed the ASA part, right?
Right.
So the ASA part, ASA plus SSL VPN and any connect VPN plus your Stealth Watch.
Right.
This is phase 1.
Yes.
You will practice this tomorrow after my 11:30.
Okay.
So what is the timing they have told you, or your time? Can you please share your timings?
They told me my time tomorrow is, I'm sorry, 1 second.
It's the 9, right?
Nah, oh, well, that's
Okay, let me check. You there? Hello?
Hey, Ram.
Yep.
I don't know what happened. It disconnected, but it said tomorrow at 10. It's 10 a.m. tomorrow for me.
No, it's not 10. It's 9 a.m. It's 9.
That says CDT. That's Central Time. But okay, I'll be on. I can be on at 9. That's fine.
Oh, see, yeah, can you see the screen?
Yes.
So tomorrow it says CDT.
Yeah, I'm not
What time?
CDT though. I'm EST, which is one
You're
more
EST.
hour. Yeah, I'm EST. Yeah.
Okay. Okay, then you come at 10. Otherwise, I
Yes.
have to start at 6:30. That is not possible
Right.
in the morning. In the evening. All right. So that's the end of story for the day.
Oh,
I hope
okay.
you enjoyed the session. I think uh, I'm very impressed because you are able to understand each and everything. Your questions are really great.
Mm,
I hope in the first attempt and in a very short time we can give a CCIE lab.
right. Yeah, me too. So, yeah, I'm ready to do this. Is there anything you want me to do tonight?
Uh, okay, if you want to access the rack, you can access now.
I mean, I don't. Yeah, Hmm.
Do you want access? I can
I
give
mean, not
you.
right at the moment. I'm actually kind of hungry. I need to go. I haven't eaten anything all day.
Okay.
But
Okay.
yeah, we can go over the class tomorrow. I'll probably go if you can pass the notes, then I can go over the notes. I think that'll be helpful.
Yes, I'll send you the notes. Plus, I'm gonna send you the complete notepad. I mean the script.
Okay.
Let me show you the script. Yeah. Where is this? CCIE security. You can see the 5516 rack commands, right?
Yes.
What's that? So this is having the end-to-end command sets. Here it's like this. Okay, the whole CCIE lab commands. So we have reached up to here. Tomorrow is 3.1.
Okay.
So up to phase 1, these many commands. So apart from that, you need to be familiar with so many other commands. Okay, but these are easy,
Yeah.
not big deal. Easy commands. Don't worry.
Okay.